Advanced Algebra, Chapter 7, Lesson 1, and we want to begin to look at how we can simplify these radical expressions now that we're doing something other than square roots, but possibly cube roots, fourth roots, sixth roots, maybe eighth roots, ninth roots, whatever. How do we simplify those radical expressions? And actually, we're not going to do anything much different than we've done with simplifying square roots. It's just that the index is going to require us to do something just slightly different, and hopefully you'll find it not that difficult. So let's review. If we wanted to simplify the square root of 48, now remember there's a 2 here that's usually not written because it's understood to be there, but the index is a 2. And to simplify this, we find the prime factors of this. Some of you do a factor tree. I prefer to do this upside down division, we call it, or I call it. I don't know if that's what we call it, but I call it that. And what we're doing is we're making a list of all of the prime factors of the 48. Because I can rewrite 48 then as a multiplication of all of its prime factors. These multiplied together is equal to the number 48. And the reason I do this is because now I see that when I multiply two that are identical together, it simplifies to the radicand, or the number 2. And then if I find two more together that are the same, I can multiply those. And then I'm left with this radical 3 out here, which I can't do anything with. So now that these are whole numbers outside, I can multiply them together, and so I get 4 square root of 3 is the simplified version of the square root of 48. Now I want you to notice something here, that this number here, the index, matches how many radicals I needed in order for this to make a whole number. So 2 square roots of 2 is what I needed, was told me, or I kind of know that now because of the index. So what if I wanted to do the square root, or not the square root, but maybe the cube root of 48? What would that be? Well, actually, I pretty much do the same process. I take the value here and I find its prime factors, and then as I multiply these together, I still equals 48, but now the index is 3. Well, that means I need 3 of these that are the same in order for them to make a whole number. Okay, so that would be 3 of these to make 2, and then I have 2 radicals left over. And when I'm simplifying, and always do as much as I can, I would never leave 2 of these. I can multiply those together. So 2, now I have to remember to put this here, this 3. Let me redo this because I'm trying to write too small there. It's not going to work. So 2 cube root of 6, as I multiply these together, would be the cube root of 48. Now it's important that we write this index here to continue to remind ourselves that it takes 3 of the same number as a prime factor in order to simplify. Now, even beyond that, let's say I wanted to do the fourth root of 48. So again, I would do the same thing. So I would have my prime factors, and these would all be fourth root indexes. And so what this tells me now is I need 4 that are the same in order for this to be simplified as one number. So those 4 2's become 1, and then I have the fourth root of 3 left over, so this would be the fourth root of 48 simplified. So again, I can continue to do this with as many roots as I want. If I wanted to do the fifth root of 48, well, I would do its prime factors as I've done before. Now the index tells me that I need 5 of the same radical. Well, I don't have 5 of the same number underneath here, so actually the fifth root of 48 is the simplified version because I cannot simplify it any further. So we're going to do the same thing we did with square roots, but the index is going to tell me how many of the types of radicands that I need in order for it to simplify to a whole number outside. So we're going to just simply expand what we already know. So that's how we do it with numbers. What about letters? And that's a little bit more difficult maybe because maybe we haven't done a lot of work with that. Now let's say I wanted to do the square root of a to the fifth. Now, how do I handle that one? Well, a to the fifth actually means a times a times a times a times a, right? So that's what a to the fifth means, 5 a's. Now, I could rewrite this then as a. And the index is a 2, so what does that tell me? I need 2 of these that come out to be 1. And then I have 2 of these that come out to be 1, and I have 1 left over, so I have an a underneath. And then a times a is a squared, square root of a. So this would be the simplified version of the variable. So again, I don't do anything different than I did with the numbers, except the prime factoring is a little bit easier. I just have to list the letters, really. So what if I wanted to do the cube root then of a to the fifth? Well, again, I could rewrite this as a, and my index tells me that I need 3 of them, so these 3 come out as a single a, and then I have these 2 left over, a and a. So what is a times a? Well, a times a is a squared, so a cube root of a squared would be the simplified version of this cube root. And again, I can continue to do this with as high as I want. Now, let's say we had multiple things underneath here. Let's say I had a to the fifth, b to the seventh. Now, we could write this as a, that's 5, and then 1, 2, 3, 4, 5, 6, 7. And then I'm looking for groups of 3, so there's one group of 3, and those 2 are left over. So I only have 1, and then 2 a's left. And then if I have 3, and I have 3, so I have these are a b, and that's a b, and then I have 1 left, and then I can multiply all these together. So I'm going to have a on the outside and a b times a b on the outside. And then I'm going to have these 2 a's. Whoops, I'm going to need to make sure I write cube root. And then I have these 2 a's multiplied back together and this b. So this is going to be ab squared times the cube root of a squared b. All right, now that can be a lot of letters and stuff written out, but I want you to understand how you could do this if you wanted to and why it works the way it works. But let me show you kind of a shortcut method to that now that we understand the foundation. All right, so let's say we wanted to do this. Well, let's keep this answer here so we know what we want and see how we can get the same thing. Now, what I would do, the way to do this shortcut, understanding what we're going on here, is I simply divide this index into the exponent. So 3 goes into 5 how many times? 1. So that means I'm going to have 1a on the outside with a remainder of 2. So that's going to leave 2 a's on the inside. So this is going to be cube root. So 3 goes into 5 one time with 2 left over. And then 3 goes into 7 2 times with 1 left over, and there's my simplified version. And you can see they're both the same. But you understand what's going on. We're trying to get groups of 3 because it takes 3 of the same in order to come out as a whole value. All right, let me do one more, and then we'll wrap this up, and then I'll do an example video where I do quite a few. Let's combine both of those together of what we just talked about. So let's say we're doing the, let's say the fourth root of, let's say 100 and, let's say 108, a to the 7th, b to the 17th, and then z to the 11th, okay? Now, we need to do the numerical side separate from the variable. So on the numerical side, we're going to do our prime factorization in order to see if there's anything that we can do here. Now, when I do my prime factorization, I'm not going to list these over here, I need 4 of the same numbers in order for them to come out. The index tells me how many I need. Now, I don't have 4 2s, and I don't have 4 3s, so the 108 has to stay underneath there as it is. That does not simplify any further. Now, what about the variables? Well, 4 goes into 7 one time with 3 left over. 4 goes into 17 4 times with 1 left over. And then 4 goes into 11 2 times with 3 left over. And so this would be the simplified version of the fourth root of 108, a to the 7th, b to the 17th, z to the 11th. Okay? So that's how you simplify a radical numerically. That's how you simplify it using variables. I showed you the shortcut, so hopefully that will be helpful to you moving forward. Again, I'm going to do another video where I do a number of problems so you can watch that and see as much practice as you want, and then you can practice those on your own.